RHS Pre-calculus presents It's Time for Pi.
Why is it time for pi? It's only 9.
It may be 9 o'clock, but it's pi or 180 degrees on the unit circle.
Unit circle? Pi? What?
Well, look here, Sonny. Unit circles are circles which have a radius of 1 and are centered at the origin. They can be represented by the equation x squared plus y squared equals 1. One graph, they look like this. As you move counterclockwise around the unit circle from 1, 0, each real number corresponds to a coordinate on the circle. For example, the real number 0 corresponds to the point 1, 0. Also, since the unit circle has a circumference of 2 pi, the real number 2 pi also corresponds to the point 1, 0. Some of the key points on a unit circle are represented by pi over 6, which corresponds to 30 degrees in the coordinate root 3 over 2, 1 half. Pi over 4, which corresponds to 45 degrees in the coordinate root 2 over 2, root 2 over 2. And pi over 3, which corresponds to 60 degrees in the coordinate 1 half, root 3 over 2. These coordinates can be used to define the 6 trigonometric functions: sine t equals y, cosine t equals x, tangent t equals y over x, cosecant t equals 1 over y, secant t equals 1 over x, and cotangent t equals x over y. By using t as the real variable for the angle measure, we can find the value of the 6 trig functions. For example, when t equals pi over 6 corresponds to the coordinate xy, it equals root 3 over 2, 1 half. In this case, sine pi over 6 equals 1 half, cosine pi over 6 equals root 3 over 2, tangent pi over 6 equals root 3 over 3, cosecant pi over 6 equals 2, secant pi over 6 equals 2 root 3 over 3, and cotangent pi over 6 equals root 3. It is important to note that the signs of the trigonometric functions for sine, cosine, and tangent are different depending on where they are on the unit circle. All of the functions are positive in the first quadrant, only sine is positive in the second quadrant, only tangent is positive in the third quadrant, and only cosine is positive in the fourth quadrant. One way to remember this is by using the acronym ASTC, or All Students Take Calculus. It may be difficult to grasp all of the relationships between these values. One method to simplify the process is by using a formula to convert between radians and degrees. If you think about a unit circle, you'll see that a full rotation equals 360 degrees, or 2 pi radians. Thus, you can set up the proportion 360 degrees equals 2 pi radians. If you divide the equation by 2 pi, you get a simplified version. 1 radian equals 180 over pi degrees. Alternately, you can divide 3 by 360 to get 1 degree equals pi over 180 radians. Let's do an example. Looking back at our unit circle, a key point is 45 degrees. In order to find the radian equivalent, all we have to do is use our equation and multiply 45 degrees by pi over 180 radians, which simplifies to pi over 4. And if we look back at our unit circle, we'll see that 45 degrees does indeed equal pi over 4 radians. Now let's try converting from pi over 4 radians to degrees. We take pi over 4 and multiply it by 180 over pi degrees. The pi cancels out and you're left with 180 over 4 degrees, which simplifies to 45 degrees, just like the unit circle shows.